Hello, Algebra 1 students, and welcome to the lesson 2.5, which is rewriting equations and formulas, or basically solving for a variable. So our objective is I can rewrite equations to solve for one variable in terms of the other variable. And I'm sorry for right now, for some reason I'm having difficulty with the camera app. And so for this video, I just won't have my camera on and you'll just be listening and following along. Alrighty, so for the essential question, or kind of as we think about things, how can you use a formula for one measurement to write a formula for a different measurement? So sometimes you have, like I could pull out, the formula for a circle, area equals pi r squared. Well, maybe instead of having A equals, maybe you want R equals something. And so how would you rewrite this formula so that you get R by itself? I will say this is probably one of the trickier parts of this unit, is understanding that basically these variables you can move around just like any other number. It's just understanding what operations are happening to them and how you can undo those operations. So it says an equation that has two or more variables is called a literal equation. To rewrite a literal equation, solve for one variable in terms of the other variables. So it's not like I'm going to get, okay, A equals 6. We want to just rewrite the equation in the case of this one in terms of R. So here's an example of this, okay? So taking a look, it says solve the equation, and we're going to solve it for y. So that means I want y alone on one side of the equation. Nothing else beside it. I don't want necessarily y equals 2. I just want everything on the other side from it. So just like anytime we solve for an equation, I'm going to just start by rewriting it out. 2y plus 5x equals 6. The next thing I want to look at is what is happening to this y. So I think maybe grabbing a different color might be helpful. Let's grab red. So in this case, what is happening to this y? Well, in this part, I know that I have a multiplication of 2 to this y, and then I also have it being added with 5x. Now, y and x are not the same variable, so I can't combine these and say 7y because this is an x. And so typically when we solve these out, we want to get rid of whatever is happening with this variable. Typically, we want to get rid of anything that's addition or subtraction first. And so that's what I'm actually going to do, is I am going to solve this out by moving over this 5x. I want to get rid of both parts of it, so I'm going to, there's an addition here. It's kind of hard to see now. I'm going to subtract it over. I'm left with 2y. 2y. 6 and 5x are not like terms. I cannot say, oh, now this is 1x. If you say 1x, you are incorrect because the 6 is not an x. This is a constant. This is a coefficient with a variable. So since I can't actually combine these, I typically just rewrite it so that it's linear. So then I would just say 6 minus 5x. I couldn't solve it out. I don't know what x is. I can't add them together. Then the last part is I want to get rid of this multiplication of 2, so I divide by 2 on each side. Cancel these out. Y equals, and in this case you could leave it like this, 6 minus 5x out of 2. You could just leave it like that. You rewrote it in that case for y. Something else though further on if you wanted to simplify, because you can simplify 6 divided by 2. 6 divided by 2 would be 3, so you could just write it as 3 minus 5x out of 2. I will accept either or. Okay, so all I did is just rewrite this equation, moving different variables over and combining what I could, but also realizing depending on what kind of numbers they are, I can't necessarily combine them. I'm not actually solving that y equals 2 or whatever. So I do want you to try these out because this part is going to be really, really important as we move forward. And I understand that right now it's just practice, and I don't necessarily expect you to get all of these correct when you go through them right now. But I do want you to try these and then come back and see if you got the correct solution, okay? So try these out because when we get to solving more equations and graphing things, this will be important to be able to solve it for y. So get that y by itself, okay? Pause it, solve these answers, and when you come back, we will have the solution. Coming on back. So solving out for y on this first one, I automatically just moved over that x, so plus x, and then I want to divide out the 5. I can do 10 divided by 5 easily, that's 2, but I don't know what x divided by 5 is, so I leave it as x divided by 5. On this problem, again, I moved over the 4x first. This is a positive 4x, so when I move it over, I actually need to subtract it. And this minus part stays with this y. That's probably one of the trickiest part is understanding that this is a positive 4x. It would be like I was adding it, but I want to undo it, so I subtract it over. This negative stays with that negative 4y. So then when I undo this multiplication negative 4, changes my 1 into negative 1/4, plus then, well, a negative 4 divided by negative 4 is 1, or just x. You could leave it as 1x, that would be the same thing. And this last one, I moved over that 6x first, so 12 minus 6x, and I divide by 3. I can divide both these parts by 3 because 12 divided by 3 is 4, and 6x divided by 3, again, I just look at that coefficient. 6 divided by 3 is 2, so I have 2x, and that is what y. And you can always rewrite it as y equals, and then, 4 minus 2x, that would mean the same thing. Or maybe you have y equals negative 2x plus 4, that means the same thing. There's multiple ways to write equations that still are equivalent or the same. So it gets trickier the more formulas you are looking at. And so in this case, they give us the surface area of a cone. And so the surface area of a cone is as follows. S equals pi r squared plus pi rl. They want me to solve the formula for that little slanted L. So it means I want to get that L all by itself on that side of the equation. So again, I'm just going to start off by rewriting the equation. That's my first step. S equals pi r squared plus pi r and this funky L. In this case, we do know that pi can equal a number of 3.1415926, continuing on and on and on. We're not going to change this pi. We're going to keep this pi as the pi symbol and just leave it how it is. And so I want to take a look at my L then and see what operations are happening to it. So if I look right where L is in here, I have a pi and an r right next to it. That shows me that this is a multiplication. Okay, so I'm going to have to undo a multiplication. And then I have the operation of addition right here, and this is what's being added. Well, to undo that, I subtract. So then I'm looking at this, and again, in this sort of operation, I would want to get rid of the addition first, so we are going to move over. And the addition's over here, so we actually need to look at what is in front of this pi r squared. And the pi r squared is positive, so to move it over, I do need to subtract it. So I'm subtracting pi r squared to each side. So then I can't combine these. I don't know what s minus pi r squared is, do you? All I'm going to do is just rewrite it in a linear form. So it makes a line. So now I've gotten rid of that part, and now I'm just left with pi r and the funky L. I said that the pi and the r are multiplying. Well, to undo multiplication, I divide. And I only want to get rid of the pi and the r. So I'm going to divide by pi and r. These cancel out, and this is how I get my solution of L by itself. And I can have s minus pi r squared all over pi r. There probably is another way you can simplify it, but I'm okay with this solution for it since it is a very heavy problem on a lot of different symbols. The biggest thing, again, is just looking at what operations are happening. Don't even worry about those symbols. Just moving them over and using those same rules that you've already been doing of using the inverse operations. So I believe the next part has kind of an on your own, and we're going to get rid of this one because we basically pretty much did that. I want to show you again how to do these ones in maybe a little bit more of a simpler form, and then we have one more problem that I want to go through together. So in this case, it says solve the formula for the red variable. So in this case, we're going to solve for b. So I have a equals base times height, right? Okay, area of a rectangle. Well, if I wanted to know, maybe I'm trying to figure out what the base is because I have the height and the area. Well, I want to think about what's happening to the b. It's being multiplied by h. To undo a multiplication, I divide by h. And to solve this out then, I would have b is the same as a divided by h, or my area divided by the height. All right, in this one, again, I want to solve for p. I equals PRT. This is your simple interest formula. I want to get p by itself. Well, what's happening to p? Well, r and t are multiplying by t. So to undo multiplication, we're dividing r and t. R and t. These cancel each other out, so that's how I get my p by itself, and I just leave it as I divided by RT. And that's it. Making sure this R and T stays together because they are multiplied together. So if you actually wrote it out linear, it'd probably look something like this. All right? And let's make sure to get to one more here. Again, take it slowly. It gets confusing because there's so many variables and we're very used to having maybe just one variable in our equations. So this is the one I wanted to get to and talking about conversion rates. So in this one it's talking about the temperature conversion. So America is really weird, or the United States is very weird, and we like to still use Fahrenheit measurements for our temperature. And so if I wanted to change Fahrenheit into Celsius, which what most of the rest of the world uses, I can use this formula right here of Celsius equals 5/9 F minus 32. Okay, so this is how I could figure out a Celsius. Maybe I want to know what 100 degrees in Fahrenheit is, you know, if I had 100 degrees in Fahrenheit, what is that going to be in Celsius? This is that conversion equation. So the problem, really what I want to do is to solve the temperature formula for Fahrenheit. So what if instead I wanted to know, okay, what if I had Celsius? Okay, instead of plugging Celsius in here and working through all of it and doing my, you know, algebraic expressions, what if I just solved it for F instead? So I'm going to actually use this page to solve it out. So we have 5/9, and what I'm going to start off by doing is distributing this already. F, and I said it would be okay if we used a calculator. 5/9 times 32. I don't know how much that's going to be. Gets me a pretty crazy number, but I can keep it in that fraction form, or of minus, I guess, 160 ninths, because I can multiply, you know, 5 times 30 or 32 and 9 times 1. So to get this F by itself, I have a subtraction as well as a multiplication. So to undo that, I'm going to add over that 660 out of 9 to each side. And again, I can't add those two together. They stay like that. And then 5/9 F. And this one, really, remember, we don't actually divide out fractions. So I'm not going to say divide 5/9 of a fraction. Remember, when we divide, we actually are multiplying by the opposite. So I'm going to multiply it by 9/5 on each side. By 9/5. So I'm just going to make it look a little nicer because this one has something like this. So we're going to make it 9/5 times C plus 160 divided by 9. All right, and that's how you would solve it for Fahrenheit. let me know if you got any questions. We'll check in tomorrow when we work on these problems.